to Projects. In this video, we will be explaining about opinion dynamics based group recommender systems. Introduction. The project addresses the issue of information overload that people confront when searching for products or services online. The volume of data can be overwhelming, making it difficult for people to efficiently obtain the information they seek. To overcome this issue, the project recommends the usage of group-based opinion recommendation systems, which produce suggestions based on opinions and ratings of numerous users in the same group. The method seeks to give more accurate and relevant recommendations by taking into account the conscious or agreement among users in group. Objective. The project's goal is to create a group-based opinion recommendation system that takes advantage of relationships and opinions among users in the same group. The method seeks to forecast group evaluations for products or services by extracting sub-opinions and using Degroots model, allowing for accurate and individualized recommendations. The major purpose of the system is to prevent information overload by presenting users with appropriate and manageable search results based on group-conscious rating. Finally, the project aims to improve suggestion accuracy and user happiness for implementing a more efficient and effective recommendation process. These are the requirements for execution. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDEL of 3.7 version is required. These are the used algorithms for implementing the project. First one is single value decomposition. Here, it is used to compute individual predictions to create a matrix that represents the ratings given by individual users to various items. SVD is a dimensionality reduction technique that helps in identifying latent features or patterns in the data. By decomposing the rating matrix into constituent parts, SVD can capture underlying user preferences and item characteristics, enabling personalized predictions for each user. SVD enables the system to create personalized recommendations for individual users by capturing their unique preferences and interests. Next one is pre-GROD, which is predict relationships in group opinion dynamics. Here, it is used to build a relationship matrix among users who have given similar ratings to the same items. It identifies users with similar preferences and considers them as a part of the same group. By forming groups based on shared opinions, the system can leverage the collective wisdom of users and provide more accurate recommendations. Pre-GROD identifies groups of users with similar opinions, leveraging the collective preferences of the group members to make more informed recommendations. Next one is Degroots model. Here, this model is used to predict group rating using Degroots model. It is a social influence model that represents how people change their opinions based on their neighbors in a network. In a context of this project, Degroots model is used to observe changes in rating scores and identify the maximum score the most users in group agree upon. This score is considered as the high prediction score and recommended to new users. Degroots model helps in identifying the conscious or majority opinion within a group by considering the influence of the user's opinions on each other. This ensures that recommended items are those for which most users in groups agree upon. Overall, these algorithms work in conjunction to create a more efficient and accurate group-based opinion recommendation systems, which significantly enhances the user experience by providing relevant and personalized recommendations based on a group dynamics and conscious opinions. Methodology. First one is to compute individual predictions. In this module, we will form a singular matrix decomposition, which is SVD, with all individual users giving ratings to many items. Next one, compute relationship between member preferences. In this module, we will build relationship matrix by looking for all users who gave similar rating into same items. If all users think product is good, then they will be giving similar rating, and based on this rating, we will form a group with relationship, finding similar users from a group with relationship also called as pre-GROD. Next one is predict group rating using Degroots model. Degroots model is based on a person name, which says that in online social networks, people change their opinions based on their neighbor's opinion. Here, also we can look for change in rating by applying this model. By applying this model, we look for similar rating score which maximum people give for same items, and this score is called as max score. Once we get max score, then we will check existing group score in matrix, and if there is any variation between existing score and max score, then we will modify similarity matrix with new max score. This max score, also called as high prediction score, and it can be recommended to new users. Applying this technique is also called as GROD. Next module is recommended high prediction items. This is the last module. Using this module, we will display a calculated max score as the high prediction score. For execution, first open the code folder. This is the code folder, and this is the dataset folder, and on this dataset we will be building the models. And these two are the main code files, and this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project. With this, we can interact with the program, and this is created by using Tkinter library in the Python. First, click on the button Upload Movie Lens Dataset. Select the dataset and click on Open. Here, 10,000 records are there. Now click on Compute Individual Prediction button to calculate rating for each user for all items. Here, 943 users are there and they are giving the rating. Now, click on Compute Relationship Preferences button to find all users who are giving rating to similar item and forms a group. Here, for the product ID 242, these are the user IDs, and these user IDs are giving 3 rating for this product ID 242. Similarly, here for other product IDs are also user IDs are giving, which are the users are giving rating of 4 for 302 product. Similarly, it will be giving for other product IDs also. Now click on the button Degroots model, then rating will change, which will consider as a true and highest rating, and this new rating will modify inside matrix. Now click on the button Group Rating by applying Degroots model. Here we can see similarity matrix modified using GROD consciousness, and now we can see the recommended items with highest prediction button. So first click on that button. Here for the product ID 242, the max score, which is modified score, is 4 and the previous score is 3. Similarly, it has modified to all other product IDs also. Now click on the button Mean Absolute Graph. Here on x-axis it represents the technique name, and on y-axis it represents the error value. Here in graph, baseline technique is not using GROD model, so its prediction error is high compared to GROD model. So close this graph, exit the graphical user interface. Conclusion: the group-based opinion recommendation system shown in the project, it is a viable method to addressing the issue of information overloaded in online search and recommendation scenarios. The method effectively determines conscious rating for items or services by taking into account relationships and opinions within user groups, resulting in more accurate and relevant recommendations. The inclusion of Degroots model improves the prediction of group ratings, resulting in individualized and high quality recommendations for new users. The capacity of system to reduce response size and deliver targeted recommendations enhance the overall user experience. As a result, the project adds to progress of group-based recommendation systems and has substantial practical application potential across a variety of online platforms.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.